Hi everyone, welcome back to Eve Math Tutoring. Today's lesson is on trigonometry, solving right triangles. So I'm going to start off with an example. So say you're asked to solve the following right triangle. So solve the right triangle ABC if A equals 18.6 degrees and C equals 135. So what you're going to do is start off by drawing a right triangle. And as you know, a right triangle is one that has a 90-degree angle. And then you can just go ahead and, okay, now let's see. In this one here, okay, so this triangle will be given to you because you would need instruction on which angle is C and which side is C, because you wouldn't know which side of your triangle is C, etc. Okay, so angle A is 18.6 and then side C is 135. So you're given this triangle here, and of course since A is here, little a, so side A is here, angle A is here, angle B is here, so side B is here. So you're given this triangle and you're asked to solve the right triangle if A equals 18.6 and C equals 135. Okay. So all angles of every triangle add up to 180, as you already know. So any triangle. So this applies for right triangles also. So this is 90, so the other two angles plus 90 should equal to 180. Okay, so if we have angle A and B, and we've got 90 degrees, A plus B plus 90 degrees is going to equal to 180 degrees. And this is a rule for every triangle, including triangles that don't have right angles. So every triangle, all of the angles, all three angles will always add up to 180 degrees. That's a rule in mathematics. And of course it holds for right triangles as well. And a right triangle is one that has a 90-degree angle. So it should have one angle that's 90 degrees, okay? And in mathematics, we usually write that with a little square. That represents a 90-degree angle in mathematics. So if we're given a question like this, the first thing we can do is we can use this 180 rule to solve this third angle. So I'm going to say angle B is equal to 180 minus this C, which is 90 degrees, and minus 18.6 degrees, and that's going to give me 71.4 degrees. Okay. Now, and we know the hypotenuse of the triangle, which is the longest side of the triangle, is equal to 135. Now we have to use trigonometry to find the other sides, okay? Now over here we've got, so we figured out this angle. So we know now that this is 71.4 degrees. So once we have that figured out, we can now solve the sides. Because I've got, let's see here. Now we could use the sine law, or if we wanted to, or we could just use the simple simple information of trigonometry. So I know that, for example, sine of an angle. So as you know in trigonometry, there's SOHCAHTOA, right? Everyone knows that in trigonometry, or should know, I should say, sorry. SOHCAHTOA. So the sine of an angle is equal to the opposite over the hypotenuse. The cos of an angle, theta, is equal to the adjacent side over the hypotenuse when you have a triangle. And the tan of an angle, theta, is equal to the opposite side over the adjacent side. Okay? So you have to know SOHCAHTOA. I always, you want to memorize SOHCAHTOA, and when you do, you can remember these easily. So sine of A is equal to opposite. Sine is O over H. So it's opposite over hypotenuse. So sine of A is opposite over hypotenuse. And we know that because we've got this right here, and cos is adjacent over hypotenuse, and tan is opposite over adjacent. So that's why I say memorizing SOHCAHTOA can help you figure out these ratios. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so that's how you can remember those. So sine of A is opposite over hypotenuse. That means that sine of A is equal to, so what's the opposite side of A? Well, that's this side right here. That's opposite to A. So that's A over, and the adjacent side, this here, the longest side of the triangle is the hypotenuse, no matter what. Okay, so we can just, write that down somewhere. This is the hypotenuse of the triangle, the longest side. It's the one across the 90-degree angle. So adjacent is the one beside A. That's not the hypotenuse, obviously, so it's going to be B, side B. Oh, sorry, not adjacent. I'm looking for hypotenuse. So the hypotenuse is going to be this part right here. So the hypotenuse is 135. Okay, so we have that now. So now we can plug in our angle. So our angle is 18.6 degrees, which is A over 135. Okay, so now, adjacent to A is this, but we're looking for hypotenuse, so that will be side C, and that would be 135. So now I've got this nice little equation, and I can now solve for A by multiplying both sides by 135. And when I do that, I can figure out that A is equal to 43.06. Okay. Now, once I have side A, I can figure out side B easily by using the Pythagorean Theorem, which is that the hypotenuse squared, so h squared, is equal to a squared plus b squared. So as you know, this is called the Pythagorean Theorem. Also referred to, or you can use C as well. C is equal to a squared plus b squared. It's commonly this one right here is the Pythagorean Theorem, but you can also write it in this form. So using the Pythagorean Theorem, we can actually find side B easily. So we would just plug in what we have. So we have C, so 135 squared is equal to A squared, which is 43.06 squared plus B squared, and then we would just solve for B. Okay, so, and when we do that, we should get that B is equal to, and you would do that, okay, let me just show you a few more steps, sorry. So to do that, I would bring this over here. So 135 squared minus 43.06 all squared is equal to B squared. So I would work this out, and then I would take the root of that number because I want to solve for B. So I would have to take the root of both sides of my equation. So this part here, so B would be equal to the root of this number, okay, that number rooted, and then I would finally get that B is equal to 127.95 as my final answer. Okay, so that would be our final answer. That is the easiest way to solve it. I wouldn't use another trig. You could solve side B using another trig setup, but I find if you can use the Pythagorean Theorem, it's always just easier to do that. So you would take the root of this number, and when you do, you should get 127.95 for B as your final answer. Okay, or you could have done that by, you could have solved for side B by using say cos of angle A is equal to adjacent over hypotenuse, and then solved that way using kind of like what we did over here. Okay, so I can show you that quickly as well. So if you didn't want to use the Pythagorean Theorem to solve for side B, you could have done cos of A is equal to adjacent over hypotenuse, which is equal to B over C, side B over C. Let's just go back and look at our triangle. Yep, adjacent, the side beside angle A is B over C. So opposite would be this side, so we're looking, so opposite would be this, so we're looking at adjacent over hypotenuse, so B over C, so that's correct. So that would be cos of 18.6 degrees would be B over 135, and then just solving 135 times cos of, so when I write this down, this means 135 times cos of 18.6, And then you would solve that and you would get the same answer. So there's two ways, more than one way. There's even more ways that you can solve these sides and angles and triangles, okay? So that is the solution. And this is like kind of like a section B, because it's like solving what we did over here. We over here instead used the Pythagorean theorem, so we went A and solved, you know, B using the Pythagorean theorem over here. And this is just from before, but we used the Pythagorean theorem to solve for B. But we could have alternatively just used this method also. So it's up to you what you want to use. As long as you can solve them correctly, then it should be fine. So let's try another example. I'm going to do another example of a right triangle question. So say you're asked to solve the following triangle. And again, I'm going to give you a right triangle. We're going to go A, B, C. And we're going to go, so this is little side B, this is little side C, and this is little side A. So that's equal to 207. This is equal to 55.2. Okay. So here, now to find angle A, I know that I could just do 180 minus 90 degrees and minus 55.2. So that's using the rule of triangles, that all the angles equal to 180. So angle A would just be equal to 34.8 degrees. So that's done. And we can plug that in. We can write that in here. 34.8 degrees. So that's finished. So now what we can do is to solve for, say we want to solve side C. Okay, so if I say cos of B, so I know cos of B, SOHCAHTOA, from SOHCAHTOA, we know that cos is adjacent over hypotenuse, so cos of B is equal to adjacent over hypotenuse. So cos of B is equal to adjacent, which is this side right here, so 207 over hypotenuse, which in this case is C. It's always the side across the right angle, which is the longest side. And we would plug in cos of B, so I could plug that in over here too. I could have done that quickly. So that would have been 55.2. And then solving for C. So now I want to solve for C, so I'm going to multiply both sides by C, and that's going to bring it up here. And then dividing both sides by cos 55.2 is going to give us cos 55.2. C is going to be equal to 363. Okay, so we just solved for side C. And then to solve for side B, again, we can use the Pythagorean theorem. C squared is equal to A squared plus B squared. So that would be 363 squared is equal to 207 squared plus B squared. And then solve for B squared. 363 squared minus 207 squared is equal to B squared. So B would be equal to the root of this number. And when we solved it, we would get 298 as our answer. So we could use that method, or we could alternatively use, another trig function, trig ratio. So we could say, okay, tan of B is equal to opposite over hypotenuse. So tan is opposite over, tan is opposite over adjacent. So tan is opposite over adjacent. Okay, tan opposite over adjacent. So using that, I know that tan of angle B is opposite, which is side B, opposite to this, over adjacent, which is side A to angle B. You're always looking at the angle when you're setting these up. So it depends what angle you have here. Like if I have an A here, these are going to be different. It's going to be different sides over here. Okay, so tan of B is opposite over adjacent of angle B. So that's going to be tan of B. So we know the angle is 55.2. So we can plug that in. And then adjacent is 207. So B is equal to 207 tan of 55.2. So that means B is equal to, same thing as before, 298. Okay, so you're going to get the same thing. Okay, so that's just another way of solving it. I prefer the Pythagorean theorem. I think it's easier than setting up another trig ratio, but some people prefer just to set up trig ratios and they don't want to work with the Pythagorean theorem. So it's entirely up to you how you would solve this one. This is method A to solve for side B, and this is method B. But there are so many ways to solve these triangles. Even the way I solved it here, you could have, started just, solved it with angle A instead of B, and then it would have been a totally different solution. So that's why there's more than one solution for these types of questions. But you should end up with the same answers for the angles. So your angles and your sides, you have to get the same answer no matter what angle you use to solve the question. So there's more than one way to solve it. So what I did is one solution, but we could have solved this using ratios involving angle A instead and using 34.8. And again, we would have arrived at the exact same solutions for sides C and B. Okay, so you do get the same solution regardless of how you solve it. And so that's how it works. So yeah, so that's, I mean, I could go ahead and show you what I mean. So like in this case, if I had started from this triangle and I was solving it using this angle instead of this one, then I would have had different ratios, but I would have had the same answer in the end. Okay, so you can even try it if you want. So like for example, if I did, if I want to find C and I want to use side A and I want to use angle A, that would be opposite over hypotenuse. So I would have done sine of A is equal to opposite, which is 207 over hypotenuse, which is C. Okay, and then I would have plugged in the 34.8 in here, and that would give me this exact same answer for C that we got over here using this. Okay, so that would give us the exact same answer. And if I wanted to use angle A to find B, that would be adjacent to A. Side B is adjacent to A, so adjacent over opposite. So we want to use side A because that's given. So opposite over adjacent, so that would be tan of A, opposite over adjacent. So if we were to use A, we would have done sine of A and we would have done tan of A because we want to use the side that's given, so we want to use this. So if I did tan of A, I would get opposite over adjacent. So this is adjacent to angle A. This side is adjacent, it's beside. Adjacent means beside. Sorry, I didn't mention that before. So when they say adjacent, that just means beside, okay? So when you have angle A, so tan of A would be adjacent, tan of A would be opposite over adjacent, so it would be 207 over B. So you would have tan of 34.8 is equal to 207 over B. So now your ratio would be tan of 34.8 is equal to 207 over B. And if you solved for B, you would get the exact same answer that we did here. So that's what I mean by there's more than one way to solve this, this triangle. There's so many ways to solve right triangles. So doing this here using angle A would give you the same answer, but you would just be using different trig functions, and your ratios would look different because you have to follow the rules when you're setting up these ratios, okay? So that is solving right triangles.